Hi folks, in this video I'm going to go through how to code this platformer in PyGame. So you can see it's got most of the functionality that you'd expect from a platformer. It's got all these different tiles, enemies, coins to collect, and even these little moving platforms. The game's got multiple levels as well, so you can see there's a little gate or a door on the top right, and when I get to that it moves along to the next level. So the functionality is pretty much all there, and it's kind of in a state where it's easy to add more things onto it. So I'm just going to go through the code and just jump straight into how to make it. So as always, I want to start off with importing your modules. So import PyGame, and from PyGame locals, import start. So this will import everything that you need to start the game. And then you need to initialize PyGame. So we say pygame.init. So this is kind of the basic starter code just to get PyGame started up. The next thing I need to do is create my game window. So for that I need to define a couple of variables, which are screen width and screen height. And I'm going to set both of them to 1000 pixels. That's how wide that game window was that I just showed you. So let's say screen height is also 1000. So with these I can now create my game window, and I will do this with a variable called screen. So screen equals, this is just a PyGame function, pygame.display.set_mode. So this function creates a game window for us. And into here, I need to put in a screen width and a screen height, which I've already saved as these variables. So that's going to create a blank window, and it's going to be just an untitled PyGame display. So I want to give it a name, and another function here is pygame.display.set_caption. So the caption is going to be platformer. And that's just going to put that in the top left of the game window instead. So if I run this now, you'll see it pops up for a split second and it disappears. The reason for that is it's just running the code from top to bottom, and then it ends the game, and that's it. So a game needs some kind of loop. It needs to be constantly running until you close it. So for that I'm going to use a while loop. So first of all I need to define some kind of running condition, and that's just going to be a Boolean value. I'll say that run is true. So all this variable does is basically says the game is running. And then I can have a while run equals true. This loop basically means that as long as this variable is set to true, which it already is from the beginning, just keep doing the code that's in here. So this is my game loop. But you can actually simplify this a little bit and just say while run. That's the same thing as saying while is true. So I'm not going to run this now, because if I did, the game would hang. It would just keep running, but there's no code in here and there's no way to close it. So the first thing I want to do is add a way of closing the game. So PyGame has an event handler, which essentially is just looking for any types of events, such as if you clicked anything on the screen, if you pressed any keys on your keyboard, and that's what I'm going to be looking for first of all. So to be able to access them, I just need to cycle through them with a for loop. So I say for event in pygame.event.get. This just cycles through all the events, and then I'm looking for a particular type. So for now, the event I'm looking for, I say if event.type equals, and what I'm looking for is when you click the X button in the top right of the window to close the game. So that is equal to pygame.quit. Now this has to be in all caps for it to work. So if you've clicked on the X button, then I want to exit the game. Well, remember, this loop just runs as long as the run condition is set to true. So all I need to do is set the run condition to false, and that's it. The game will now exit. So to finalize and to close all this out, remember I initialized PyGame at the beginning, so let's just quit PyGame. Run this code now. I've got my game window, it says platformer in the top left, and if I click, I can close it down. So that's good. I've got the game window, but there's nothing displayed. So the first thing I'll do is I'll load a couple of images just to get something onto the screen. I'll add a comment up here. Remember, this has to be before the game loop. You don't want to keep loading images into it. You just want to load all that kind of stuff into memory right at the beginning. So we'll say load images, and I want to load in a sun. So my sun, I'll say sun image equals, for loading pictures into PyGame, it's got its own function, which is pygame.image.load. And then in here, I just provide the path to this image. So all of my images are stored in an image folder. So I say image/sun.png. And now I just copy this down and I make a second one, which is going to be for my background. So my BG image is the same thing, but this one is going to be called sky.png. So with these both loaded, now I want to be able to constantly draw them onto the screen within my game loop. So I'll come up here and I'll say, well, if I want to show something onto the screen, if I want to put an image onto my game display, I need to use PyGame's blit function. So first of all, I need to tell it what display I'm going on to. I only have one, which is my screen variable. So I say screen.blit, which is the function for putting an image onto the screen, and then I define the picture itself. So I want to put on my background. I'll say background image, and then the X and Y coordinates, which will be 0, 0. So it starts in the top left and it fills the entire screen. Then let's copy this down, do the same thing, but this time I change that to sun. And I'm going to put this around 100 pixels, so kind of be in the top left. If I run this now, it doesn't actually do anything. The reason for that is you need one more function at the end here. And this is called pygame.display.update. Essentially what this means is that throughout the code, you're going to be putting all of these different blit functions and draw functions. This one last line here essentially tells Pygame, okay, take all those things and now actually update the display window with those instructions. If I run this now, I get that updated background and I've got my little sun up here. The thing to note here is that the order in which you're putting these things onto the screen is important. So first of all, I've got my background and then the sun is drawn over it. If I was to flip this round so that the sun is drawn first and then the background, you'll notice it disappears. It is still there, but what's happening is the sun is being drawn up here, and then on top of that, I'm drawing the background. So you have to be mindful of the order of these things because you might think that something's not working. It's just simply hidden under something else. So the next thing I want to do is actually put on some kind of level onto this map. So at the moment, there's not really anything there. It's just a background. There's different ways of creating these map levels. The way I've done it is, is one of the common methods, is essentially you just split the screen into a grid, and then you have sort of preloaded images. So I've got dirt blocks and grass blocks. And then once I've split this into a grid, I just define for each grid position whether I want a grass block or a dirt block and so on into that position. So to illustrate what it is I'm meaning, I'm going to draw this little grid first of all. You don't need to follow this bit along. You don't need to copy this into the code because it's not really part of the game. It's just to demonstrate what I'm wanting to show. So I've actually coded this little function separately. I'm just going to copy this into here just to save having to type it all out. It's just a define draw grid function. So I'm just going through a range and I'm drawing a bunch of lines onto the screen with a color of white, and these are the X and Y coordinates. So before I do this though, before I run this code, I want to define how big each of the tiles is going to be that's going to be on my grid. So I'll come up here and I'll just have a section for define game variables. So to start off with, just to keep it simple, I'm going to set my tile size to 200 pixels. So all this variable is saying is that each of those, if I'm saying I want to split this 1000 by 1000 screen into individual grids, then each of those grid tiles is going to be 200 pixels. So I'm going to end up with 1000 by 200. I'm going to end up with 5 by 5 grid. So I just need to draw this function, call it within here. So we'll say draw grid. Again, you don't need to follow this bit along. If I run this now, you can see this grid that I was talking about. So I've now split this map or split this background into 5 by 5 rows and columns. So now I can use a list, and within this list, I can store a value for each of these tile positions. And depending on that value, I can put either a dirt, or grass, or whatever into them. So that's quite straightforward. I can now create this list just down here. And I'll just call this my world data. Okay, it's going to be a list. So remember, each of those rows essentially is a list on its own. So what I can say is in the first row, I just want, i.e. the very top row along the screen, I just want that to be all bits of dirt. So we'll just put ones in there because that's what's going to correspond to dirt. And because I've divided this into 5 by 5 grids, I need to have 5 values in my row list, but then I now need to have 5 of these rows. All right, so the second row, I just want to have a block of dirt. Essentially, I'm just drawing a dirt outline. So I'm going to have a block of dirt on the left, then the middle is going to be nothing. So I'll just put zeros in there. And then finally, I'll put in another 1 on the end. So this is row 2. I can copy this down for row 3 and row 4. And in my last row, I want the same as my top row. I just want it to be solid blocks of dirt. So that's my individual rows. Now I need to group all of these into one master list. So that's where this additional square bracket is going to come in. And I just need to make sure I add commas here to separate all of these individual list items. Okay, so now I've created this world data list. I need to be able to read this list and from this actually extract the useful information that's going to allow me to put images onto the screen. So up here, I will create a class. This class is going to be called world. As always with a class, you need to start off with the constructor, which is your init function. So init, this takes the self argument, and is also going to take a data argument. So this data is going to be the world data that I eventually supply to it. All right, so first of all, I want to load in the image. So we'll say load images, and for now, all I have is dirt. So dirt underscore image equals, again, I use that pygame.image.load function, and this is in the same image folder, and it's called dirt.png. Essentially now what I want to do is I wanted to be able to run through each of these rows one by one, and within each row, I want to go through each of the tiles one by one, or columns, and just say if it's a 1, do this, if it's a 2, do that, and if it's a 0, do nothing. So for that, I just need to run for loop. So we'll say for row in data. Now data is this list that I'm going to be supplying into the class. So for row, meaning that iterate through each of the individual rows, and then within each of those rows, for tile in row, we look at each individual column or each individual tile. So if that tile is 1, then that means that we have a block of dirt. So that image, the image that I'm going to be putting onto the screen, is this dirt image. However, remember I've split this into a grid of 200 by 200 pixels. So I need to make sure that each of these dirt blocks, or in fact any block that I load in, is correctly sized to it. So I need to scale it up to that size. And for that I use pygame.transform, and transform has a number of different functions, but the one I'm looking for is scale. So I want to scale my dirt image, and the size that I want to use is just tile size for the X and tile size for the Y. So it's just going to make this 200 by 200, but it means that I've got this flexibility that I can change this to whatever I need to, and it's going to resize the tiles to suit. So I've loaded the image, but within PyGame, that alone isn't really enough. The image itself is, I suppose, is just a picture, but I need to know where I'm going to put it onto the screen. I need to give it X and Y coordinates. Essentially, I need some more data on it, and that's where rectangles come in. So this image basically is a rectangle, right? It's a square which is 200 by 200 pixels wide. PyGame has a function for taking this image and converting it to a rectangle object. And that rectangle can then store all this useful information about where its coordinates are. And from that, I can then use later on to do any kind of collision that I need. So I'm just going to set this all up front. I'll say my image rectangle variable. And this is where I use my image, which is the image I've just loaded, dot get underscore rect. Essentially, it just takes the size of this image and it just creates a rectangle from it. So now that I've done that, I can give it an X and a Y coordinate because I need to know, based on where I am within this grid, where it's going to show it on the main game window. So image rect.x, which is the X coordinate of that rectangle, has to be defined based on where I am within this list. So the X coordinate is going to be increasing as I go through each of these items here. And I'm going through each of these items here within this for loop. So I can just add a little counter for this. So we'll just say, start off first of all, col count, which is my column count, is 0. And then as I iterate, I'll come down here. I want to just increase that by 1. So my col count increases by 1. Essentially means that as soon as I've gone through one of these tiles and I've moved on to the next one, increase that variable by 1. So now I know that I'm moving along within this row. When I'm done with all of the rows, when I'm done with all of the columns within each row, I've moved on to the next row. Well, I need to be able to increase my row counter as well. So we do that within this for loop instead. So we just unindent here and say row count is increased by 1, and make sure that I set it first of all to 0. So I need to make sure that's defined before I start. All right, so now I've got column and row counts. I can use these together with my tile size to determine where on the screen I'm going to put this. So the X coordinate is just going to be, remember the X coordinate is going to increase with the column count. So at this point it's going to be 0, then it's going to be 200, 400, 600, 800. So that's increasing by my tile size. So I can just say column count multiplied by tile size. Then I do the exact same thing, copy it down for my Y coordinate, except this time instead of column count, I'm using row count. So when this code is done, it's going to load in, or rather, it's already loaded in an image. It's then going to scale that to 200 by 200 pixels, and it's going to take a rectangle from it. But then nothing's going to happen. I'll move on to the next item, and this is just going to overwrite this data. So I need a way of actually storing this somewhere once I'm done with it. So this world data isn't really going to be useful for me in the actual game. This is just essentially my level data that I load into the game once when I create an instance of this world. But out of this, I need something more useful. So I'm going to have a list that I create right at the beginning of this. So I just say here, self.tilelist equals, and I just create an empty list. So as I go through these, I'm going to add these values to my tile list. But I have two values to store. I've got the picture itself, and then I've got the rectangle of the picture. So because I've got two values, I can just save them in a tile variable, and I would save them as a tuple. So the first value is going to be my image, and the second value is going to be the rectangle. And now that I've created this, I can add this to my list. So my self.tilelist, remember this is just a Python list, so I can use the append function from Python to add items to this list. So I just add this tile. So the idea is once this set of code here has gone through this entire list, it's going to extract all the useful stuff. So it doesn't need to do anything with the zeros. It can just ignore them. It'll just take all the ones, for now anyway. It'll have more values later. But for now, it'll take all the ones. From that, it will take their coordinates for the rectangles, and it will store this in this new, more useful list for us. All right, so with this done, I can now create an instance of this. So I can just say here, my world equals, call the world class, and feed it the world data list. Now I just want to run this to see if it works first of all, in case I made any mistakes. No. So it all works, but nothing's actually displaying yet, but I do know that all this kind of stuff is happening in the background. And we can verify this by outputting this tile list that's being created, just to get an idea that something's actually happening in the background and things are working as intended. So in my game loop, I'll say print world, which is the instance I've just created, and from that, print the tile list. So if I print this out, you can see down here, I've now got this list, and within each list item, which are separated by these commas, I've got a tuple. So the first item within the tuple is the image, and the second item is the rectangle. So you can see this is actually working now, and it's producing this information, and now I need to actually use that to create something onto the screen. And that part's pretty straightforward. I've got the data already processed. That was the kind of time-consuming part here. Now I just need to create a new method within this world class. So this is going to be define draw. And all I need to do is just iterate through this tile list that's been created. I'm only going to be using this, this init function only happens once when I create this instance. But then afterwards, I want to be able to draw that on the screen constantly. So I want to iterate through that list. So I just say for tile in self.tilelist. So let's go through each of the items in that list and then draw them onto the screen. So remember for that, I used the blit function before, screen.blit, which is exactly the same as I used here. So the first variable is the picture itself. Well, this tile is going to be giving me one of these items, right? So it's going to go through one by one, go through these items within that list. And that itself contains two pieces of information within it. So I can access them with indices. If you remember, if you just type in, for example, if you're working with a list and you want to get a particular value from it, you just use square brackets and you put in whatever you want in here. So 0 would give me the first item within it. So I know that I need to put in the image, or I need to blit the image from this value, and that is at my index 0. So I just type tile 0, and the coordinates I want from it are stored in the rectangle. So I just type tile 1. So that's going to take that picture and put it in the location of the rectangle coordinates. So now the only thing left is to actually call this draw function within the game loop. So let's come down here and say world, which is that instance again, dot draw, which is that function or that method that I've created. If I run this now, there you go. You can see I've got the grid still split up into 5 by 5, and now I've got these dirt blocks drawn along and the outline, which is kind of tying in exactly with what I've got here. I've got ones on the outside. So now adding anything into this is actually really straightforward. The kind of time-consuming part was getting everything set up. But now let's say I want to add grass blocks. Well, let's load them in first. So grass image equals, again, exactly the same, pygame.image.load. And this is going to be in the same directory, but now these are called grass.png. So I've loaded them in, but I need to assign them a different number. So let's just change these bottom rows to 2s. Now, this is quite straightforward. What I've got before is if tile is 1, do this for dirt. Well, let's just copy that, put that below, and now just change that to 2. So if tile is 2, do the exact same code, but just change this to grass. All right, so let's run this code now. And there you go. It's quite straightforward, and now it means that you can easily modify this as you go. However, this isn't really very practical. This is way too small and the tile sizes are way too big. The reason I did this was just to kind of give you a clear idea of what's going on, and I wanted to avoid having a massive list to start with. But realistically, you want a lot more grid points, and the game that I built to start with, that platformer, had a tile size of 50. So that meant that 1000 divided by 50 means I had 20 by 20. So if I now change my grid size to actually show what it looked like, this is what that game was like. So that would mean that this list, this world data list, would have to be much bigger. It's going to be 20 by 20 values. And I have got this separately, which I'm going to copy and paste into here, and I'll add this into the description so you can paste this in if you want to follow this along. I did not type this manually. This would be way too time consuming and tedious, and it's so easy to make mistakes when you're doing something like this manually. I've got a level editor, which I can run up and show you just a demo. So level editor works in the same way. I've got this grid showing up, but you can see I've got load and save buttons, and it allows me to basically click anywhere on the screen to create these additional blocks. And if I just keep clicking, I cycle through whatever I want to put on there. So that's what I've been using to create these levels. And then I can save that data and then load that back into my world, into the actual code. So the only reason I've really done it like this is just to kind of demonstrate it, just to give you an idea of what's going on in the background. This isn't really how you want to be doing it within your actual game. And if this is a bit off-putting and intimidating, don't worry. This is not how it's going to be done in the rest of the videos. So I should be able to actually run this now with this new grid, and you can see it's all filled in now. It doesn't matter that I've increased the size of it, because that for loop just goes throughout all of them. It's essentially, it doesn't matter how much you put in, it's just going to keep going through, and it's going to take all the data and produce this level. You notice though, I've got different numbers here. I've got 7s, 4s, there's a 6 here. None of that is shown here, but the reason is I don't have a way to process them. All I've got at the moment are 1s and 2s. But like I showed here, it's really easy now that the bare bones of it are done to add on more things as I go along. So that's going to take quite a bit of time. I'm going to leave that for future videos, but I think for now this is a pretty good place to stop. So if you found this useful, then please do leave a like, and if you want to stay up to date with these, then feel free to subscribe. Thank you for watching.